Jæja, góðan dag. Ég vil byrja að bjóða ykkur velkomin á þennan fund OpenShift og svona örlítið open source. Ég vil byrja að minna á að við erum að taka upp þessa kynningu, þannig að þið vilja ekki verið í spotlightinu. Dagskráin, hún á þessa leið að Fevsi, hann mun byrja að ræða aðeins svona innganginn að OpenShift og svona þessu open source ekosystemi sem í kringum Red Hat dæmi og í framhaldinu tekur Magnús við og kemur með kynningu á OpenShift, svona sínir showcasear hana. Svo ætlum við að taka smá pásu eftir það, taka smá kaffi og taka síðan Cloud Native Application Development í lokin. Fara svona í gegnum, svona hvað þarf að gera til þess að brjóta upp monoliths og þess að þar. Lokum minna á að ýmislegt gagnlegt til hjá Red Hat sem að mér varst allavega vert að nefna. Að fyrir þá sem ekki vita þá Red Hat með sér síðu sem heitir developersredhat.com sem fullt af góðu efni varðandi bæði OpenShift plattformin, bæði að sækja til dæmis Red Hat Container Kitið sem í rauninni standalone kistluumhverfi fyrir eins og OpenShift og svo Red Hat Enterprise Linuxin sem hægt að fá þá development útgáfu af, fá development license. Og svona að lokum að nefna sem dæmi að Red Hat þáttakandi í að þróa Eclipse T sem þá Docker-based þróunarumhverfi, web-based. Það áhugavert kannski fyrir suma að skoða það. Og það svona áhugaverði fítur sem að detta þar inn varðandi svona Cloud Native Development og Debugging sem að oft svona getur verið hausverkur í Cloud Native heiminum. En ég ætla bara að gefa orðið til Fevsi og hann byrjar. Takk.
Hello, good. So, hello, welcome for coming. My name is Fevzi Konduk. I work as a partner alliance manager or sales, basically taking care of relationship with some of our partners. And I'm based out of Stockholm. And the topic that I'm going to talk about is why open source, why Red Hat, why now, to give a little bit of inspiration. So that's the main goal with this session. So if we look at innovation and the drivers, what drives transformation in the market, it's based very much on open source. And the main innovation things like in big data, mobile, social, cloud, containers, DevOps, etc., they all come from the open source world. It's not created by a proprietary vendor inside of their walls. So if we look at big data like Hadoop, it's again open source. If we look at the biggest mobile platform, it's Android. Give me 1 sec. Android, which is also open source. So a lot of innovation is happening in the open source, and open source is actually enabling a new type of services that we didn't have previously. So the entire infrastructure of Facebook is also running on open source. They don't buy a Solaris server rack or Windows and operate on that. They take Linux, customize it, create a Facebook image out of it, and then that's how they deploy things. Cloud, per definition, is open source. All cloud providers are running on open source. Azure runs on open source. Google, Amazon, all of them, all of the players do there. Containers is also something that happened in open source. Started a little bit with Docker. Actually started before that. It gave it the prerequisites required for it to happen. And DevOps is also something that happened in the open source community. So what is open source? In order to define open source, for me it's a development model, nothing else. In order to explain what that development model is, we need to look at what the traditional development model looks like. So if you do traditional development, it means that you're a company, you produce software, with different characteristics, which means you have X number of employees that actually work on this piece of software. And this is what is denoted there, like maybe one company has 1,000 engineers or developers, maybe one has 15,000, maybe one has 50,000, but it's a set of a number of developers that actually work on your piece of software. The great thing about traditional development is that you get low risk because everything is so well contained, spaced out, and tested. And now let's have a look at open source. So you have millions and millions of developers. So you see the bubble is a bit bigger than these individual bubbles. And there are millions of projects also out there. And what you get with this is that you get a very high level of innovation. You have a lot more man-hours or man-days of code actually put into the open source community, which means that innovation is being driven there. So my question would be, would you like low risk or innovation? Actually, most people say, I want low risk and innovation. And this is what an open source vendor like Red Hat does. Reduce the risk, so you get low risk, but you harness the innovation from the open source society. So that is exactly what we do in a very cost-efficient manner. So what we do is that we capitalize on the open source community. We produce low-risk software. We bring the innovation at a very cost-efficient way. And of course, we have a very wide product portfolio, everything from operating systems, software-defined storage, middleware, cloud, etc. But that's basically what we do. So open source has actually changed characteristics. It used to be like this. Someone sitting in a cellar, preferably in Finland, starting something called the Linux kernel, had this mad idea. And now it's actually eating up the world. So it's actually changing the world quite radically. So if you read analysts, and if you look at what's happening to the proprietary or traditional software companies, they're changing. So in terms of having the most strategic IT vendor, it's not IBM, SAP, Oracle, these traditional vendors. It's more like the new vendors, like Red Hat, Google, Amazon. They're expected to be the biggest winners, according to Goldman Sachs at least. Red Hat is one of the most innovative software companies that Forbes magazine publish. So it's a top 100 list. And do you know how many software companies are in there? 3. And IBM, SAP, and Oracle are not there. So it shows that something is changing. Then, of course, it has been quite fortunate for Red Hat, going open source since day one, 25 years ago, up until today, when the market has changed, the prerequisites have changed, there has been a lot more coding being done, a lot more innovation in the open source community. A lot of changes are in there, which has led that we have been quite successful. We've had consecutive quarters of growth for almost a decade now. So it's a kind of an interesting journey to be there. We do quite a lot of revenue. This is a large sum. $3 billion is a lot of money, especially selling free software. It's a bit interesting. So you can make money on it. Usually you see these slides, we have 98% of Fortune 500, but we have 100% of the Fortune 500 airlines, banks, healthcare, and telcos. So it shows that open source is really eating the world. You get a lot more open source today than what you did 5 to 10 years ago. It's really, literally eating up the world. If we look at the other section of this presentation, I'm going to talk a little bit about DevOps, containers, microservices, and try to use a lot of buzzwords, but maybe put them in a real-life context instead. So, The role of IT is changing, and it has changed quite dramatically over the last 15 years. I mean, Harvard Business Review, quite an esteemed paper. They write articles that people believe they have lots of credibility. Back in 2003, they wrote, IT does not matter. When we look at this statement today, it feels, was he mad? But at that point of time, what he said was actually true, because if you look at the market around that point of time, it was more like utility, you know, electricity does not matter for this company, or the water pipes, or that there is a sewage. It's a necessity in order to do business. But a lot of things started to happen around this time frame in the millennium shift. Internet happened. So something happened there. Internet came, it turned into an explosion with iPhones, apps, iPads, etc. So when internet came and we got the availability in our devices, the way we consumed IT started to change. So it started to have a lot of impact on the business. So back in 2015, now the analysts are saying every company is now a technology company. And this is true because you innovate and you disrupt markets, you totally decimate different segments of markets by using technology. It's the driver for business nowadays. And if you take it even one step further, now everybody's saying every company is a software company. If you read what Tesla believes themselves to be, they say they're a software company, but they make cars. So they innovate through IT. So in the digital era, some things has changed. We no longer do an IT system design and we believe this will be fixed for 15 years forward. It's a very, very long time span. So this means that there is a high pressure to come up with new products, new services, new business models, how to handle partners, how to handle money transfers, how to give incentive to different partners that you work with. It puts a lot of different characteristics that you need to devise an IT organization that is capable for change. So the new status quo is constant change. And if you're not in constant change, then you have a problem. So with constant change, what you do is that you take ownership of your own innovation. So you need to drive your innovation. And the easiest way to do it is to become a software company and write services that are critical for your business need. I really like this picture. It's really dangerous to quote one of the most famous quotes here. But I think what Darwin said for more than 100 years ago is still valid. So if you change the word species to software companies, it's pretty much true still today. It's not the strongest software company that survives. It's the one that is most responsive for change. And a good example for that, or I don't know if good is the right word, but an example of that is Kodak. So I think it's not a surprise for everyone. Kodak has gone bankruptcy. But Kodak was super dominant in the field of photography for more than 100 years. They had a lot of employees. They had a lot of money on the bank. What most people don't know is that they basically had almost every patent for digital photography. I mean, they have the brightest minds, they have the experience. What happened? They were not responsive to change. That is why they failed. They didn't understand how to use this new technology. They made decisions that said, we believe in that printed piece of paper we called photography, and that was what they tried to do. But the entire business shifted, so it was totally decimated by other companies. This is also true for cool companies. I mean, I think most people have heard about Uber and what they're doing. in US, it's killing the taxi companies because you get a fresher car, you get it faster, you get it cheaper, you go from point A to point B. Each individual driver has a rating, so you get better customer service. So it's eating up the entire taxi market. If you try to order a cab, you have to wait 15 minutes. You click Uber, comes instantly. And at least for me, that comes from Sweden. You know, the taxi driver takes you from point A to point B, and then he says, "Sir, you forgot the tip." What tip? I mean, I paid the charge. So in Uber, everything is handled. You do everything in your app. The driver comes, you sit in it, you go to point B in a nice car. Someone is nice, feels good about his own town, and everything is great. But cool companies like Uber is also feeling the pressure. There are other competitors like Lyft that are innovating, coming with cooler ways to travel and to reach out to users. So this comes back that the new status quo is change. You need to change. You cannot just sit down and relax because you innovated once. So what does this mean in terms of IT? Who knows waterfall model? Nobody heard of waterfall? Okay, good, great, thank you. Woo! I mean, everybody talks about it today like if it's the worst thing that was ever invented. But in all honesty, the waterfall model works. It creates solid piece of software. It's a very structured way of actually doing projects. It's really good. But challenge, it takes really long time. You can't decide what an app looks like and then release it 5 years later. And in 5 years' time, we're running iOS 27 or whichever version. It's not even compatible with whatever we deliver. So we need to do things in a different way. And that's why we start talking about agile development. So it means that you get new features continuously, you have these sprints, you produce some functionality, you provide value constantly to the business or to the application or the project that you're running. Agile is great, so why is there a need for something new? Because in agile development, what you don't handle is operations. You push out new code, new features very rapidly, and you throw it over the fence to operations, and they, oh, what am I going to do with this piece of software? Which ports are going to be open? Which interfaces did you change? So it becomes a bit of a problematic. So DevOps, it's more about the culture and how you develop things. So it has to do with things like pushing the responsibility that it actually works to the developers as well, which is actually good. So this has also changed the architecture of applications. So when we did waterfall, we were doing monolithic applications. In case you don't know what a monolithic application is, it's very simple. It's like you have a large binary file, and it does everything you want. It's not separated into services or anything like that. Then later on, when agile development came through, we started seeing the need to separate. So we took very brave steps, and we said, oh, you have the web tier, and then you have the backend tier. If you were even braver, you split it into 3 tiers. So you had like 3 different teams working on development, separated from each other. In today, with DevOps and microservices, we're talking, with DevOps and agile development, we're talking a lot about microservices. And microservices is not magic. It's just an architecture of how you separate application functions and logic and then orchestrate through them. So it is like a monolith, but it's separated. And they have a little bit of different use cases on them. And to get a good microservice architecture is not super easy. It requires a well-thought process and a little bit of experience. I think one good example here is, let me try to think of something. Are you familiar with Chaos Monkey? Yeah. For those that aren't, Chaos Monkey is a service that Netflix has in its microservice architecture. It has only one purpose, and it is to kill other services. So all it does is it shoots down your services. So when you are developing in that environment, it's not, if my service goes down, what should we do? The developers and the operations, they know my service will be shut down minimum once a day, probably more times per day. And that's why they need to devise an architecture and approach so that it automatically spins up new instances of this microservice, etc., so that they always have constant service. So, it's a different way of thinking. In the traditional design, I mean, if you said, let's cut the cable or kill the process, everybody said, no. It takes 3 hours to start the service, and so many requests are coming through, so we need to throttle and make sure that, it doesn't spike, so we can distribute the load of the traffic, blah, blah. It's a complete different approach. This also has an impact on the deployment and the packaging. We used to do physical, which was great at that time. And then 15 years ago, something magical happened, virtualization. I remember when I saw it the first time, I was amazed. I said, this is the future. It actually solves a way of how you package things. So I called it a PC emulator, but the word virtualization took foot. So I think it's a good word as well. And now we're talking about containers. So without being too technical, containers is like a super mini version of a VM, of a virtualized machine. It uses resources. You can do a higher density in those. And it goes hand in hand when you need an architecture like microservices. Let's say that you have one application, you divide it into 100 microservices. You don't really want 100 VMs running and having an operating system overload per instance, different mechanism for it. And of course, this has also changed how we deploy things, where we deploy them. So we used to have data centers, we have hosted, and now we're talking a lot about cloud. And cloud is also, and these different deployment models fits in different areas because these are born later, the microservices. They're cloud native by definition. So why have I been talking about it? Because Red Hat actually has an offer here. We have a platform, a container platform, Red Hat OpenShift container platform that takes care of everything from doing DevOps to microservices to containers and actually to run them on-prem or in cloud. So if we do a buzzword bingo here, let's say that what OpenShift provides is a complete hybrid application platform where developers and operations teams meet, so it fulfills DevOps. It's built for both traditional and next generation cloud service native microservices applications. It's done, you use it for development, you use it for test, you use it for management, you use it to run, orchestrate, and scale your container-based services in one production-ready turnkey solution. So of course, this innovation comes from the open source community. We didn't invent every piece of this puzzle ourselves. So we picked from quite many open source projects. We created our own umbrella open source project. And then we have created different commercial solutions, on-prem, off-prem, cloud, etc. But if we look on why it is so popular and why we are so successful with it, it is because containers are a really nice way of actually doing things. And what we did 3 to 4 years ago is that we sat down and we tried to figure out how can we do the next generation workloads in the future. And we had to bet on some technologies in order to be successful there. So first of all, we realized that if we're going to have containers, we need to look at how things are with the virtualization. Today, if you take a VM from vendor X move it to vendor B, it doesn't work because the VM image format is not standardized. Yes, most of the vendors have now converters, so you can actually run some sort of script, it can migrate, but natively the format is not standards-based. So we put our horses on a container format called Docker, and then we started working on it. And then we realized that is great, but how is that different from what was happening before? So we created the container, what is it called?
Container runtime interface, open container.
Yeah, Open Container Initiative. And from the Open Container Initiative, we actually came up with a lot of different container formats or technologies inside of these formats for actually using that. So we're actually one of the top contributors to all of these projects. And the way you need to do orchestration when you're running containers is a little bit different. You have different needs when you operate something that looks like Netflix. So we looked at one of our competitors or partners, but let's say it like that. So we looked at Google at that time, 4 years ago, and we said, okay, they know how to manage things at a large scale. So Google is actually starting and killing around 2 billion containers per week. If you look at a traditional management solution, there is no way you can achieve that. You can manage 10, 20, maybe 100 endpoints, but you can't manage 2 billion transactions in a week. And you need to understand which is tied to what and doing where. So Google had actually open sourced it, but at that time, there was no support for it to work with Docker. It only worked with Google's own proprietary interface. So we came in and started writing a lot of code. And at that time, we had lots of competitors like Cloud Foundry. Everybody was doing different things. Today, Red Hat is best placed to take advantage of the growing container adaptation because we bet on the right technologies. So we are already there. Our competitors today are jumping the ship and running with Kubernetes. So Docker tried their own, like Docker Swarm. All of our competitors tried something different. But it seems like today, there's no question about it. Kubernetes is the orchestration layer that you use with containers. And of course, there are some challenges when you want to adopt containers. We have competitors that say, sure, just run Docker, put whatever you want there, or run this and put there. And what we say at Red Hat is this is probably what you will end up with, a sinking ship, because it's not only about putting the container somewhere. You need a platform to handle every aspect of your needs. So you have needs like security, chargeback, monitoring, compliance, logging, self-service. How do you change management? How do you automate deployment? How do you build? How do you test? How do you orchestrate all of these things? These are not defined by the container format or a container as such. This is handled by the platform, and this is why you need a complete container platform. If you don't use a container platform, you need to implement all of these services yourself and maintain it. And that's hard work. If we look at one of our reference customers, it's a very large Nordic bank. And this is a public article, so if you go there, you can actually read which very large Nordic bank it is. So they were doing traditional development pipeline. I mean, this looks pretty common if you're a software developer. You commit somewhere, then you have a build server, then you have a test server, then you have a QA server, etc., etc. You have UAT. Of course, you can't put anything in production before you need to put it in a pre-production environment. And then your production environment might be on the cloud, on-prem, etc., depending if it's hybrid or not. So for this customer, it took weeks to go from commit to production. That doesn't sound like a very long time if you're like releasing a new application for the first ever time. But if you think about it takes 10 weeks to apply a security fix, or you have a spelling error in your graphical user interface, 10 weeks becomes a very long time. So they wanted some assistance to reduce this time. So if we take a real-world examples, I like taking Spotify as an example. They update their streaming cluster live 3 times per day. That's their maintenance window. 3 times every day it's upgrading. And it doesn't mean that the music stops while they're doing it. So 10 weeks is like a really, really long time. So we took an approach. It's time for change. So can you integrate and automate all those steps? Yeah, for test, for development, absolutely. Can we do the same for operations? Yes. Can we put these two together in some way? Absolutely. And this is where you get DevOps. So basically what we're doing here is the same thing as Henry Ford did on the conveyor belt. You have small stations that small things are happening and everything is standardized. Everything is following the same model. And we did this with OpenShift, with Red Hat OpenShift. And for this large bank, so this is for the core banking application. This is not some UI stuff or just the mobile terminal. It's for the core banking application. And the reason why they need it there is because it's very critical. And they need to be able to put changes to it in a much faster pace. So after running it a while, they realized there is no need for a pre-production system. I mean, it's ridiculous. This is a container. This is also a container. Why am I testing everything there and then spinning up a container that looks identical and test it again? So after running this a month or so, they said, this is ridiculous. Remove pre-prod. Poof. And what happened here, the end result, is that going from 10 weeks from pushing code to go out to production, they're down to 20 minutes. And that's a game changer for them. So if they need, they can actually push something out into production in 20 minutes. It's a great game changer for them. So if you didn't read the first slide, I work in sales, so I need to do this. What's the business value? So with containers, of course, innovation, faster development, increase operational efficiency, and put in new processes like DevOps. So we did a survey on our existing customers who migrated to OpenShift, and roughly on an average, you got a 66% faster application delivery. At the same time, you got 35% increased developer productivity. It means if you have 100 developers, now your capacity to create new code is like 135 developers, and that's a great innovation. And at the same time, reducing the infrastructure cost by 38%, because you're running different technology that allows higher density. So Red Hat OpenShift now becomes like a universal abstraction layer. So what you do and care for are the big A's up there, which are your applications. And you write them, and OpenShift becomes the abstraction layer to the underlying infrastructure. So it can be on-prem, virtual, or out on the public cloud or in your private cloud. So it becomes a truly hybrid cloud that allows you to run from on-prem to any cloud in a very easy manner. And what OpenShift does is that it abstracts the services away, so you don't get any lock-ins. So you say, what about storage? There is a storage service in OpenShift. If you deploy it here, yeah, it's maybe on disk or on Asana or wherever. If it is here, it's running on the storage tier of OpenStack. It's probably running on a Ceph cluster. If you're running here, yes, it's using Amazon storage, but you are going to the OpenShift storage service, which means that when you move these workloads, you don't need to migrate your applications. You just push them, you deploy them to different places. So that was my 30 minutes of fame.
Okay, all right, so yes. So I thought I'd be talking about trains instead. No, you'll see what this presentation is about. So, in order to give you some insights and context about technology and stuff like that, I need you all to help me and imagine that you live in the 19th century, so in the 1800s, right? So in order to kind of help you, assist you in imagining that this is the case, allow me to present your family and your colleagues and so on. Here we are. Great. We have super fancy clothing. Look at our kids. They look so well-mannered. That's cool. Okay, so this is us, 1800s. So, and we work in a company, just for intents and purposes, makes it a bit more easy. We work in Copenhagen, actually. And we work for a company that is selling stuff from on the marketplace in Copenhagen, and we bring merchandise from Vilnius in Lithuania to do this. But we're not alone. We have a competitor who is bidding for the favor of the customers as well. And both our companies, we deploy the latest, the very latest in travel technology. Allow me to present to you the horse. It's good stuff for people in the 1800s. So, and with the power of the horse, to get merchandise from Vilnius to Copenhagen, it's about 30 days of travel. And then we're losing 3 to 4 horses because we're whipping them really hard. So, but during the 19th century, something amazing happens. Innovation, which is just mind-boggling. And it's called the train. And here on picture, you can see some traditional Catholic priests blessing the train. It is a part of the normal 19th century delivery pipeline, the blessing. Do you bless your software as well? No? No? How can you be certain that it's not getting cursed or might be cursing your customers? Well, anyways, these are early days. So we don't have millions and millions of people using trains at this point. And the thing is that horse salesman has come to us to warn us about this thing called a train. And they have told us that it's not natural, this train. And it's very dangerous. And we listen to them, basically. And do like most people in our time, we don't use trains. We put all our cards on horses instead. And that's just how it normally is. All people don't adapt a new technology from the start. This is Gartner's famous adaptation curve. So, but the problem is that our competitor, they did not listen to the horse salesman. And they implemented the train. And now we're in a situation where they can bring merchandise to the market in Copenhagen 30 times faster than us. And let's stop the history lesson at that point, and please raise a hand if you recognize this situation. Yes. So, companies that did not adapt the train in the 18th century, they got brutally disrupted by people adapting the train. And this is, I mean, the case today in the 21st century as well. But instead of train, think like, oh, it takes 5 weeks to get a virtual machine. Then you're using a horse. And you should be really considering things. This is the business case for changing stuff. It's been the same for like eternity. And the business case is that your business can continue to exist. So it's quite serious. And if you don't change, you will become a footnote in history like many, many, many other companies before you. So it's just how things works. So at this point, you're probably thinking, trains! You have to buy trains. And you wouldn't be wrong. I mean, if you're using trains if you're using horses in a train's world, you're pretty much screwed. But the thing is that there are a lot of companies like pitching it's the train to you. And the question is, who has the right idea? And our approach at Red Hat, which Facey pointed out, is that instead of like making a bet on one thing, we believe in the fact that if you have a great idea, you should share that idea and architecture and blueprint for it with the rest of the world, because we've seen that then some people will look at your idea and think about other things, and at the end, you get a lot of great ideas and better solutions. So this is the open source ecosystem. But we keep coming back to like, what is the good thing to make a bet on? So we've been here for a long time, like Facey pointed out, and we've been in this open source ecosystem, just emerged in it forever, as long as we existed. And that gives us a capability to like see an idea and see that people are gathering behind this idea. Developers are pouring into a project, or it's coming from somewhere which is sustainable, and we package those ideas then and make them good enough to run a bank on. So a bet on Red Hat is basically just a bet on that more people is more likely to come up with the next train idea instead of a few people in some locked environment would be able to find the solution. So let's talk about some open source solutions from this ecosystem then, which is really cool. So yeah, there are a lot of them, like over 1 million projects, and Red Hat has a lot of different solutions in many different areas. So I'll just select a favorite of mine, which happens to be OpenShift. So at this point, enough with the slides, I think. I am not a big fan of slides, really. I mean, what if I'm just making shit up? I promise you, there are horse salesmen that comes to you every day and just makes shit up, just by showing something on a PowerPoint slide. So this is OpenShift. This is how it looks, if you wondered. So I'll just make this a bit bigger. Is this okay for you? Yes? Okay, cool. All right. So I'll do some actual work here. So I'll call this Magnus Dev. Magnus Development Environment. Click. Did you see that? Did you see how quickly it said, like, has been created? You know what happened? Oh, let me tell you. Some pretty amazing stuff. So, a brand new software-defined network was created. Uses a technology called VXLAN. Do you know what VLAN is? You're segmenting your networks with it. So, we're using a software-defined version of it, exactly the same if you look at like a frame. So, anyways, so we created a new VLAN, and on top of that, a new IP network onto which we can deploy stuff. And that took what? Half a second? Possibly less. How long does it take if you go to your network department and ask them to create a new VLAN and IP network on top of that? You're using a horse. Okay. Right, so now I'm inside of my environment and I'm gonna deploy some stuff. This is the self-service catalog of OpenShift. Neat. Cool. I can select some different stuff here, which is just pre-populated, but I could, just customize this to whatever point I like to have. Okay, I will just select a language, which I like to deploy. I'll select PHP. Call this PHP 7.0. And no, that's not it. Hang on, and I will just change this to PHP. Is this correct? I wonder. Hang on, sorry. Just have to be able to see, copy this. Zut, go back. And what I'm doing now is deploying an application, a container. But I don't want to be bothered on the details of how to create a Docker container. So I just point at the source code, my PHP source code, and this will trigger a source to image system which deploys a container for me. So, cool. And just to show you some really useful stuff, I'm going to show you how to do a canary test. Do you know what that is? So there are a number of zero downtime deployment techniques, canary, blue-green, A/B, for example, and you need to do that in order to be able to release 3 times a day, because then you don't need to have, you can't have downtime each time you deploy. So this is one of the ways to do that, and it's called the canary deployment. So I'm deploying my application, my simple PHP app here on 2 different versions of the PHP framework, 7.0 and 7.1. So as you can see, my PHP app actually is already deployed. It's quite simple app. Hang on, I will actually, can I not have full screen? Here we go. Just do like this. You can still see it. Need to be able to switch between tabs. Okay, cool. And I have the version which is running on 7.1. Okay, so that's quite common. One app, and I need to see if it works across multiple versions of PHP. As you can see, I have a communication entry point to each version of the app. Canary test. I just pick someone out. It's you, because you are an expert of this application. And I'll just ask you, well, please go ahead and access the new version of the app, and then you say, well, it's crap. Don't give that to the customers. And yeah, then I'll don't. So, and when you're happy, I'll point everyone at the new version. Okay, so that's one way. Let's do blue-green, which is that you switch between versions. Blue-green, call that. And click. Okay, now I get a communication endpoint which points at version, at the 7.0 version. Looks like this. Wait, I should show this in a better manner. If I just take up this prompt, you can probably see this still. Like while, true, do, sleep for a second, do a curl to this, grep out version. Let's see. Okay, cool. So now I just get an infinite loop, and I get back the version which this endpoint is pointing at. So Now we're gonna do the blue-green switch. Exciting. We're gonna introduce the new version of the app. I'm just pointing at that 7.0, 7.1 instead. Just go ahead and save that. And now I can see it's pointing at 7.1. And I go here and I can see, well, cool. Wait a minute. It was a horrible release. It broke everything. Let's go back quickly before anyone notices. Zut. Okay. That was simple enough. Oh. It's the blue-green switch. Okay. That was simple enough, wasn't it? I mean, in order to do this, normally you would have to like integrate with your load balancing team. Maybe they're running a NetScaler or something, and maybe it's not automated at this point, so on. But this is all in a box. Cool. Okay, let's do an A/B. A/B deployment is when you just take it piece by piece instead. Just like, let's take 5% of the traffic and send it to the new version. And when we see that that is all good, we do like more and more and more. Okay, create a route, call that A/B, and just split traffic across multiple services. And let's have 25% of the traffic to the new version. I'm fairly brave. Okay. So just copy that link and just put this into my little loop so we can see how this works. Okay, traffic going to, hello. Did I do Magnus? Yeah? Yeah, okay, sorry. Okay, right? Yes, sorry. Okay, so good. We have the load balancing. So then we can go into the route because we could see that this was working properly, and we just adjust the weight to have it 50-50, for example. There we go. Now it's 50%, yeah. You understand how it works, okay? So it's quite neat, quite simple. And this can all be managed by like an application, a self-organizing agile team, for example. And you don't have to spend any time in trying to automate your old load balancers. Cool. So that was a quick demo. Pretty cool stuff, though, just considering that I just used very little time to do it. How much time do I have still left? Plenty. Unlimited. — 15 minutes? 40 minutes more? Yeah? Okay. Well, that's super cool. Then we can do all sorts of cool stuff. Okay. So these are some of the features of OpenShift. But then actually, because we have some time, then I can go into and show you more cool stuff, more demo. Or do you rather me to go back to the PowerPoint slides? Raise a hand for a PowerPoint. PowerPoint? No. No, not one? Okay. Let's do demo. Okay, scaling. So scaling is quite important, especially when we're doing stuff like A/B, for example. If we're putting more traffic onto like a specific service, that needs to maybe scale out a bit. And this is also, I mean, some of, you could say, like a prerequisite to get nicely working microservices architecture, that we are able to scale things. And let's do that. Actually, can someone else, you're the expert of the application, please help me to, you want to come up here? Okay, cool. So just expand that here. Cool. Okay. So now we can see if you can figure out how to get like more of this. Yes. Yes. Absolutely more. Don't be shy. Yes. Excellent. Okay. Yeah. That's all. Oh, that's all good. You didn't destroy anything. So good. Applause. Yes. 4 different instances of this application. So let's look at that actually. Maybe it's just again smoke and mirrors to make you believe that this is actually some working piece of technology, which is 7.1. So just take this. Cool. And just we should have like we should get 4 different IP addresses back. Oh wait, that was not. Remove this. Bloop. 1, 2, 3, 4. Yeah. Cool. Okay, so that seems to work nicely. And then we can just, well, we can add more things, obviously. We can scale more. And how you scale is also something that, so most common, I think, is that people scale based on like CPU utilization or something which ties into like how much usage do we have of an actual app. But we can do custom metrics as well. So I was at the KubeCon and talking this year, and I met this cloud company in Holland, or they came from Holland, and we were in Copenhagen, right? So, and they told me of this amazing thing they were doing with OpenShift. So their concept of cloud was that they bought like 18-inch racks and put it in people's houses. Okay, so, and the deal was that in exchange for them being able to put an 18-inch rack inside of your house was that you get free heating. So this would not work in Iceland because you have really cheap heating already. But in Holland it's like, whoa, because we pay a lot for heating. And then the custom metric, they had this custom metric, and that was temperature in the house. So as the temperature was low in a house, they will route more cloud workloads into that house to heat it up. So custom metrics can be pretty cool. You can do some awesome stuff with that. And then as, oh no, the house is getting really warm now, so we need to scale that. We need to scale that back down. And so you can do that as well. And it's quite simple. And obviously I'm clicking in a GUI now, but this could be a REST interface, this can be a CLI, whatever you like. So. Yes, I mean there should be a temperature gauge here or something. Yeah, cool. But we can see. So this is our container. Can we go into this mode here, for example? We can have a look inside of the actual container. So this is life inside of a container, how it looks like. And if you're into Linux, you will see something which like, and that is that PID1 is not init or systemd. It's instead Apache. So, and this is how it looks from inside of the container. And what a container is a sandboxed process, even though Facey made some comparisons to virtual machines. It's actually nothing like a virtual machine from my perspective of a deep technical level. And it's just a sandbox process. But inside of the container, I cannot see the rest of the world. That's basically all that matters. And yeah, I have some files here and etc. Cool. All right. So this is a pod. A container inside of a Kubernetes cluster is called a pod. Or, well, a pod is actually the atomic unit, the smallest thing that you can manage. And sometimes one pod equals many containers, but typically not. It becomes overcourse. But let's look at some pieces of this. So you were familiar with a route, which is the communication entry point into the cluster. So how do you get traffic to your application running inside of this segmented off VLAN and IP network? That's using a route. But the thing is that, I mean, I showed you where we scaled things up and down and etc. And that would be chaotic if you were using virtual machines in a traditional environment. Why? Well, because each thing that pops up gets an IP address, for example. How would we keep tabs on this? Well, then we need a service layer, of course. So the route here, for example, our AB route, we can see that it points to some different services. For example, the PHP 7.1 service, which in turn points at containers, pods. So if we go ahead and, for example, again, scale things up in the Magnus development environment, bloop, 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 bloop. Run 4 instead, and we can see that there are 4 containers running. What happens here on a technical level is actually that each time a container comes online, there is a concept called a health probe, which keeps tab on if this container now actually up and running. Can we maybe reach a simple endpoint on the app to make sure that it's okay to receive traffic? And when it's up, it notifies the service layer and allows traffic to actually hit the application running inside of the container. And when we scale down, same thing happened. We just say we're gonna shut down, send no more traffic, and we can allow any existing transactions to drain, and then we shut it down. Or we might be like, nasty and just kill it. But probably we want sessions to drain. Okay, so that's how that looks. So this is the service layer, how things are discovering each other. And we can go into a container here. Just take one of them. Hello. Am I still connected? Yeah. There we go. Terminal. Aha, okay, sorry, this is because of me using like multiple tabs, because there is some magic here. Okay, type E and V, yeah. So service discovery inside of the container happens using environment variables. So this is quite nice from an application perspective, because when we start up, containers, as you might know, they are stateless. So they don't keep data, right? I mean, it's a zip file. There's nothing fancy here, really. It's just we put stuff inside of a zip file. And when the application starts up, it knows nothing about the world. And it might have like a application front end wants to talk to a database, for example. How do we find the address of the database? And that is how that happens. Environment variables inside of the container. So from the application standpoint, we can then just say, well, your database is gonna be this environment variable, and in using this way, we can share stuff. Like addresses, ports, things that changes all the time. And we can also share information such as like secret information. maybe usernames and passwords and stuff like that, using a concept called secrets. Right, so that's a bit. Metrics, that is something which you don't typically just get for free if you're just running containers on a computer. So here we can see the utilization of our containers. And as you can see, this is not a lot. This is 60 megabytes of memory that is consumed here in my simple PHP app. Imagine that this would run in an instance of an operating system. Well, the minimum memory footprint of an OS in general, generalizing, you can make tiny, tiny operating systems. But in general, I would say around 2 gigabytes. That's quite common. 1-2 gigabytes as a minimal size. And this is 60 instead. So we're saving quite a lot of memory here. Yes. And when we're looking at CPU utilization, well, it's 0.001 millicores. It's quite a little CPU utilization here that we're actually using. So this is how Facey were able to, with a straight face, just say, well, you will be able to get utilization up. It's going to be much more effective because of that's how the world looks like when you're running containers. Quite different from running virtual machines. But what more? Oh, logs, logging. Because that becomes a problem, right? If nothing is kept, no state is kept inside of the container, and when I kill this container, it will just be gone. Totally gone. And a new container will be started up, perhaps, but that container is just history. So how do we keep logs? Application logs. That might be important for us to be able to look at. So as a part of OpenShift, we have something called, we have a logging stack. You might be familiar with, for example, the ELK stack, Elasticsearch, Logstash, and Kibana. So we have a modified ELK stack, but EFK. Elasticsearch FluentD is fetching the logs, and Kibana is presenting them. This is something that you get just out of the box in OpenShift. So these are the logs, the std out stuff. Let's go here and click View Archive. Oh, now I am redirected to the Kibana interface. And here I have, this is a modern log tool where I can search for specific events, get them graphed over a timeline, like when did this error message first appear? It was in December 1st, 2014. Oh my God, it's been broken forever. And yeah, so we can do some really cool stuff here. So for example, let's just change this, for example. Now I'm just getting logs for this specific container. But maybe I want to look at the, oh, wait, that was deleted one too much. Now I get logs for everything inside of this project, for example. And we can go back to my Magnus development environment. So this is also a Kubernetes namespace, if you're into Kubernetes. But like I said, much more, also IP network. And we do role-based access controls per this project. So I can say, well, Facey only gets read access. I can do anything. And you are allowed to not delete stuff, but you can do like scaling and things like that. So that's quite useful. And automatically, when I get access to a project, I can be allowed to look at the logs for just this project. So this is an environment that does multi-tenancy quite nicely. So we have a lot of service providers that builds like PaaS as a service and just provides them to customers. But something that Facey touched upon, a benefit, is that you put OpenShift like a warm blanket over everything which is broken. And this is how your development team's environment looks like. Doesn't matter if the underlying infrastructure now is automated. If you have installed one node using a DVD, put it into a server and just install it manually, blah, blah, blah. All that doesn't show. This becomes how they interact and work. And also, if you're thinking about hybrid environments, like what happens when we have a data center and a hosted solution and some public clouds and all sorts of things, then the biggest problem, really, is ways of working. The problem is actually like context switching and optimizing systems. But if we have one way of working when we're in our data center, one way of working when we're in Amazon, one way of working when we're in Azure, one way of working when we're in our hosted environment, that makes it really difficult to optimize how we work, optimize processes, optimize delivery pipelines and whatnot. When we're using like specific services all over the place. Basically, that is very difficult to get done, yet to see someone that, I mean, naturally, companies like Spotify or something who has literally thousands of engineers, they can do whatever they like, but most companies are not like that. They have a handful of engineers, which will need to put these hybrid puzzles into place. And that is absolutely a benefit, because that makes it possible for us to move between different providers. You haven't realized it yet, this like public cloud thing, which is quite neat, gives us infrastructure as a service without much of an effort, except for our credit card getting locked away somewhere. But think about Oracle. Think about Oracle database. It's a simple piece of technology, right? It's an SQL database, has some ACID compliance. We like that. But it's quite, in its essence, a simple piece of technology. But so many companies are locked into this single piece of simple technology. It's just one. Now imagine public cloud, which is a myriad of different, very specific services which only exists in one place. Imagine the type of lock-in you could get there. I started this discussion about a bit talking about change, right? And when you cannot change, if you're locked into a public cloud provider, that might be it for you. If you cannot change, if you cannot adapt, if all your processes and ways of working and everything is just has a prerequisite, and that is that you are a customer of Amazon, then you cannot change. You have to abstract. That's super important. Right.
Can I ask about this point?
Yes.
I guess this is probably the biggest selling point of
Yeah, well, I think it's a selling point for abstracting away from sticky solutions. Yeah. Yeah. So you use Kubernetes here. So this is not OpenShift specific stuff. If you have a Kubernetes cluster, then you're fine. Yes, correct. Yeah. Absolutely. I'm absolutely not arguing against you there. Yes, correct. If you speak like native Kubernetes to a solution, that is it. But OpenShift is a bit more than that. It's the self-service catalog. It is lifecycle management for your containers. It is, for example, as a part of OpenShift, you have a software-defined network. You can have software-defined storage. Yeah, it's a way to do hybrid, but there are many ways to do a hybrid. But this is something that thousands of customers are doing very successfully. So, but there's never like one single silver bullet. Yeah, well, it was just a PowerPoint slide. It wasn't reality. Anyways, but abstracting away from stickiness is something that you get with OpenShift. And also regarding lock-in, because everything we do is open source. There is no proprietary standards. There is no secret sauce which you have to keep on paying for it to function. If you are not happy with our software, I have a good news for you. You own the software. It's open source. You only buy support from Red Hat. You cancel the support subscriptions, keep on running the software. And that's typically not something you get normally. That's absolutely not something that you get in a public cloud. Then it's like, well, your credit card was denied, and then we're shutting this down now. Yeah. Anyways. Regards to storage, for example, you can use in Kubernetes, you can use a bunch of different storage technologies. So we have, you can run Gluster, for example, one of the software-defined storage solutions, hyper-converged as containers in a cluster. That's quite neat, but you can also consume storage in like all different versions. You can literally do fiber channels still, if that's a good idea for you, or NAS or NFS, or this could be a public cloud providers underlying storage service, all getting abstracted away from. So, with that, I think I should at least, we'll see how time is, but should, I think, explain what you saw. Yes?
Can you elaborate a little bit on how you handle entry points into the container platform?
Yeah.
For example, multiple sites versus this and that location.
Yeah. Okay, so cool. I should probably still show this in point. It will be easier to understand if I show the slide. This is the underlying infrastructure. We don't care about that. You can mix. It can be bare metal, virtual machines, public cloud. Just mix and match as you like. And when you like migrate between these different technologies, it's just, yeah, allows you to do that without getting significant downtime. If you just, yeah, come up with something new that you want to run containers on. So this is the cornerstone of any Kubernetes cluster and OpenShift as well. It's called the node. And the node runs containers. It's quite simple, straightforward. And when we talk about containers, we talk about container image when it's at rest on a disk, dead, doing nothing to harm the world. And when it's running, it's called we'll say it's just a container, or it might be a pod. Which is then the orchestration concept in Kubernetes. So they are orchestrated across many different nodes then. So that's neat. Then we have the master. The master is the keeper of the cluster. And it has some different tasks. For example, it does API and authentication. So all the stuff that happens in the cluster goes via the API. If you're in the GUI, it's going to talk to the REST interface. If you're in a CLI, it's going to talk to the REST interface. So that's good. One entry point into the cluster to do stuff, and there is nothing as an unauthenticated API call. Everything is authenticated. Then we have a data store. This is etcd, if you're familiar. Core OS, by the way, invented this, which we now have acquired. It's an open source project, and it's a key value store, and we use that to look at the current state of the cluster, which might be like, there's 5 containers running. And then we look at the desired state, and that might be, there should be 10. And then the master's responsibility is, please remedy this. Desired and current state should always be the same. Okay, or aim for that. Then we have a scheduler. The scheduler is the thing that puts containers onto different nodes, pulls it out of a registry, and runs it on a node. Then we do orchestration. So like Facey said, when Google invented this, they were doing it at large scale, billions of containers created and destroyed in a week. Like when you log into Gmail, for example, did you know that a new container gets spin up just to present to you your inbox? And when your session times out or you log out, that container gets destroyed. That's how it works. So no wonder that they're like creating and destroying like billions of containers. But then you need a system that works at scale, and that system is that you have labels. A container has a label, beer. Node has a label, also beer. Beer container, beer node. They get a match. So that's quite a simple system, how it works. And you can create policies. You can have affinity, anti-affinity ruling. Maybe this container should never be on the same physical node as this other one. Or maybe they should always be on the same node because of latency reasons. And you can create these policies, and then as well, obviously the scheduler looks at utilization of nodes, and then it does the actual placement. So then we had the service layer. We talked about that. You saw it with your own eyes. It's not just a slide. And health and scaling. Actually, I didn't show you that, so it might be just making up stuff. Let's take this container, which is just delete it. Die. Now it's died. Now, desired and current state is not the same. But it is now the same. Good. So that was quite quick. That was how the health stuff works. And scaling, you've seen that worked nicely as well. Unhealthy pods gets remediated. Application data gets stored in a storage layer, which we don't care about what that is. We have the routing layer, which we talked about, and you access it in any way possible. So I'll go back here. So what about multiple data centers? What is the architecture to work with when you have 5 different physical locations that you want to run on? Well, you can stretch a cluster, OpenShift cluster, I mean across infinite space, basically. What is a bit sensitive is that the masters, they need to have quite low latency between them because they are in an active setup, and they are exchanging information a lot. So you cannot put them on like separate places in the world. That won't work, really. But the latency between a master and a node, that can be at least 160 seconds without that being a problem. So nodes can be put wherever you like, but if you're looking to keep one cluster intact on one physical place, the masters is the key here. And there are basically 2 different approaches to this. regarding how to build environments across multiple like physical locations. And there is one that this should be provided by infrastructure. This is the old way of thinking. Like imagine Veritas cluster server type thing. The infrastructure should just fix my broken app so it can fail over between locations, because you didn't consider high availability when you designed the application. So it's a bit of a hack. But the second way of doing things, if you look at how public clouds are built, do Amazon offer you ability to fail over between Frankfurt and Ireland? No. No, they don't. The whole concept is built on that you should have a distributed application architecture and put some eggs here and put some eggs here and have a global load balancer that fixes the availability. And that is probably how I would advise you to design OpenShift across multiple sites as well. Make separate clusters. Put load balancing in front and go. Okay. So we talked about OpenShift and some cool tools, but there is a point to make as well. So Facey talked a bit, and me also, about change and the importance of change. And living in the open source ecosystem, which is constantly changing, we have learned that it's quite important, and this is, if you can answer this question, how to create a culture within your company which enables change. That is how you get a company which can persist the test of time. Like when you have a company that can be for 100 years, 200 years. Then you need to have a culture in your company where you don't end up like, train? Well, I never gonna keep on using that horse. So how do you end up, how do you prevent that from happening? So I'd like to call out some enemies of change and some change enabling culture which we live at Red Hat every day. 1. This is change anti-pattern number 1, the thing that prevents more change in the world than anything else. And there's a word that describes this situation. And I'd like you to call it out, if you can figure it out. What word am I looking for here? You know? Fear. That is basically it. Fear. The word that I picked quite randomly or like arbitrarily was distrust. Distrust. So I think you're gonna take my job. You're talking about like improving my solution and automating it and containers and other stuff, but I think you're after my job. And so I don't trust you, and I will absolutely resist whatever change you are bringing to the table. Right? So how do we solve that? Well, you know how to solve that because you trust your friends. You trust your family. That is, you need to be transparent. You need to be collaborative. Not just force something down someone's throat. Have a discussion. And don't lie. Be upfront with any difficulties or problems or challenges that are. And when you promise something, deliver on it. And then you get a system of trust, and then you can have a change. Next, change anti-pattern number 2. What word am I looking for, do you think? What? Doubt, yes. I will say that's correct. So it's so I picked the word risk. So the thing is that when we people, human beings, don't have knowledge about something, we see risk instead. This is how human beings function. It comes from when we lived in caves, and outside of the cave it's dark. I won't go into the dark, I will probably get eaten. There will be wolves and bears and saber-toothed tigers and stuff. I will stay in the cave. Not knowing something makes you read risk and see risk. And obviously, if lack of knowledge makes people see risk, then you need to be good at bringing knowledge to your colleagues and your teams and explaining to them that, look, this change is gonna mean that instead of like punching the same keys on a keyboard all day long, you're gonna work with important stuff that matters the most for this company. This is gonna be a huge change for your career. You're gonna put all the cool buzzwords in a CV and then get a higher pay raise or whatever. You need to talk with people and explain and make sure that they understand what's happening. Otherwise, they will see risk, and then they will say no, and don't want to change. Change anti-pattern number 3, and the final one on my list, and also a personal favorite of mine. What is this? What is happening here? Describe it in a word, if you can. Chaos. That is very good. It is absolutely chaos. This is a motorway and it's completely full. And then I think it's a good idea to take additional 1,000 cars and try to cram it onto this already full highway. What happens then? Chaos. What does not happen? Change. When you have a team which is just like keeping their nose over the water line and just juggling a million things, just preventing, like making every effort for everything not just explode and burn or flood, then you have no room for change. This is also about trust. Trust that if you give a team free time, 10% free time, 20% free time is something, a value that Google choose. Then you have to trust that that team will improve. They will look at the stuff that they're doing and try to improve on it. Try to maintain some technical debt which is piling up and preventing them from being effective long term. It's quite simple, really. I mean, nothing of this is probably like, whoa, what? You cannot like force people to work 150% and then require them to learn something new? What? I mean, that's just plain and simple truths. 2 things to remember from this presentation. 1, most importantly, create a culture in your company which enables change. Make a collaborative culture that invites people to promote their ideas, help people, inform them, enable them. And then secondly, use some pretty cool stuff that comes out of the open source ecosystem. For example, OpenShift. That was all. Yeah. Yes. Okay. So I didn't ask. Do you have questions? Hang on. Yes. Excellent question. Yes, you can. So we've been working with Microsoft for about 2 years' time now in order to get Kubernetes running efficient on Windows. So they had a lot of challenges because the Windows kernel wasn't really equipped to do secure and efficient sandboxing of processes. So there was a lot of development which was required in Windows. So Linux, on the other hand, had like 15 years head start. This is like the technology which is containers is literally 15 years old. So it wasn't a big thing for containers to happen in Linux. But yeah, so, and I don't think I can easily just, oh, wait. Okay, I will just pull this out for 1 second because there will be some secret stuff and then some stuff which I can show. It is there. It's time for roadmap. Okay, can I just go there? Dun, dun, dun. Let's see. Oh yeah, no, I removed that. Okay, just shortly. Here we go. Here we go. Okay, in the spirit of open source, let's share some information. Here we go. Okay, so this is roadmap information for OpenShift container platform until March next year. So let's see. Windows containers. So it is, yeah. In January, it's tech preview. To have a Windows server node in an OpenShift cluster. And if everything works well, then during the first quarter of next year, that will be in production. Yep. Okay. Yeah, that's what I'm talking about. No, not master. Yeah. That, I mean, so, yeah. Even Microsoft are moving away from Windows. You should also take that step. Yeah.
Is the OpenShift container platform running on OpenShift container platform? Are you handling your own containers and nodes by your own program?
Yeah. So how it gets deployed, the whole software you can choose actually, but I would recommend you to run the platform itself as containers, absolutely, because that makes the upgrade process much easier. Yeah. Yep. And there's some, yeah. Any more questions? Yeah.
This is less about technology, maybe.
Yeah, it's okay.
Let's say you have a multi-tenant setup.
Yeah.
Or executes or something like that.
Yeah.
You have to charge them somehow for use.
Yes.
And they will have to self-service to see what possibly could be the
Yeah.
bill. Is there something?
Yeah, good question. So this is actually, so the quest or the how you do that today is that as a part of OpenShift there is a piece of technology called CloudForms, which allows you to do chargeback. So you connect that to the cluster and I will say to you, the utilization in this project is this and this much. and you configure this yourself. I mean, how much does CPU and memory cost? By the way, that is the most difficult part to answer. How much does like 1 kilobyte per second network throughput cost? Difficult to answer, and typically how you go about creating chargeback schemas is that you start by just guessing. It's like t-shirt size type stuff. And you might start off by having more fixed costs. And then as you learn, you get better at giving good estimates. And you might start off by doing like showback, maybe, internally, just like look at stuff and try and come up with figures that works. But going forward, so this is end of this year, this will be a functionality which is built into OpenShift.
CloudForms.
Yeah, CloudForms will not do that. And this is coming out of the acquisition of Core OS, which has much more advanced capabilities with that. So next release is gonna, so 4.0 release is basically when we really merge all the cool stuff that we got from Core OS. Yeah.
So as a continuous
Yeah.
of that, you talked a little bit about optimization.
Yes.
Before.
Yes.
This acquisition, I'm not quite sure what CloudForms actually, what capabilities they have. But is always a rough connection with the costs?
Yeah. Yeah.
Optimization of workloads, placement, and things like that.
Yeah.
Would that also then be some kind of optimization?
Yeah. So.
Suggestions or something?
Yeah, yeah, it does do right scaling. It can like give you advice on, so this virtual machine is maybe not utilized fully and stuff like that. But yeah, there will be those features will move into OpenShift itself. Yes. Yes. Yeah, that is 4.0. That is literally, we're merging Tectonic into OpenShift and introducing a lot of, well, basically all the goodies out of that. Operator framework, for example, and Quay. So then you get registries which can be like global registries. And I mean, that is just a superior technology for doing registries. So then you'll get that. It will be super cool. Yeah. Yep. More questions? No? All right, but then I think we are done. Thank you so much for engaging. That was collaborative. A lot of questions and stuff. And also thank you for help with the demonstration as well. Yes.
Jæja, nú vorum við að spája að ljúka þessu með síðasta fyrirlestrunum hjá honum Fefsi, þar sem hann ætlar að fara yfir Cloud Native Development. Þannig að byrja alla svona að fara að koma sér fyrir, svo að Fefsi geti byrjað. Takk.
Yeah, my name hasn't changed since last time. I still work in sales, but I have also changed my role a couple of times. I seem to like Darwin a lot. So before I was sales executive, I was actually a principal architect. And before that, I was actually a developer also once upon a time. So, and that's why I'm going to speak about the cloud native application development. So let's see how that goes. So, I mean, this is a good question. Are you happy with the speed of your current application development? Yeah. But given the disruptive nature of digital economy So developing innovative products and getting them to market quickly is the only way to play the game. It's speed to market, how fast you can develop things, how fast you can adapt. So, I mean, of course, you need to have quality products. I mean, if it doesn't work, you try, and then you try again. And then if you're born in this millennia, then, you know, everything has to be consumed in less than 2 seconds. Otherwise, you lose your interest. So speed is very important. It's essential for survival with the current business culture that we have. I know myself. I get angry, very angry, when I order something through internet and it's going to be delivered by the Swedish post office system, PostNord. Then I get a phone call. Maybe I ordered like 4,000 kilo of stone because we're going to do the payment, so I don't want to collect it myself in my small car. It's impossible. I have to go 100 times, break my back, lie in bed. I work in IT, my back is hurting. So I want it delivered, and usually you get an SMS that says, we will deliver it on Tuesday between 0800 and 1700 hours. I don't want to sit home the entire day on a weekday. I have a job. So, I mean, this kind of things really makes it horrible. And then I have a special person in my life, goes, orders some creams from apotea.se, and it says, will be delivered by today. She sees on the app, the delivery car is there, it will be here in 5 minutes. And I'm sitting the entire day and get angry. So speed is very important, and what we accept and don't accept is changing because of what we're being exposed to. So are these things familiar to you? I mean, we're not seen as an innovative company. New deployments stop all other work for a week. Recruitment fails to attract skilled developers. I think this is really a pain point when you are trying to transform, to move into becoming a software company, a technology company. I mean, if PostNord would say, I want to have an architect or a developer, I would say, don't go there, don't go there. So this becomes a problem because the new talent, specialized talent, skilled talent wants to work at cool companies with cool technology. So if you don't use latest and greatest and cool and relevant technology, you can't attract relevant people either. It becomes a challenge. We all heard about security. You know, security is slowing down. So we need to change our ways of how we work with security. Pushing new releases production takes months. You can count on production failure with new deployments. These are common problems that customers are having and still having today. This is not like 100 years ago. So we talked about the status quo. The cost of it, by not changing, is the longer that you wait, the harder it is to catch up. So organizations that haven't modernized their application architecture will fall further behind, and the entrance will move even faster and get even a longer försprång. I forgot the English. Okay. There will be even more steps ahead of you. It will be very difficult to catch up with them. So, in essence, cloud-native app development is all about becoming faster. Faster in many senses, and we're going to try to slice the elephant and understand what we mean with that statement. But the key word is faster, speed. So how do you become faster? So, I mean, so we need to segment it, and we need to tackle what is hindering us from becoming a bit faster. And in order to become faster, we need to address this in multiple ways. So we need to look at how we increase our speed of delivery and how we update our applications. So deliver faster, important. We also need to increase the change for existing applications in order to adapt for changing behavior of users, etc. So we need to be able to push code a bit faster. You need to increase the speed of development for new business applications to utilize new business opportunities. If you fall behind, it's not good. And then you need to innovate faster, so increase the speed of innovation. I think most successful companies, the coolest software companies, they are the most innovative companies. And if you do a research on, which companies do you want to work for, it's usually the innovative companies that are on the top list of where people want to end up working at. So innovation is really happen. And to do that, you need to establish and experiment with culture inside of your organization. And that's why we are usually also talking about culture inside of organizations. And to change a culture is very difficult. To start a new culture is super difficult as well. It takes 2-3 years to establish a new culture. If you start a new company, the first aspects that you're worried about is how do I define and set my working culture? Because you want a special type of conduct and you want people to work in a specific way. Culture are not laws. It's about behavior and how we expect others to behave, what is normal or not. So that is a very important thing as well. So if we look at some customers that we've had, so Key Bank, we help them to deliver faster. You can read the quotes yourself, but on day one, when they acquire a bank, they can actually put 10 changes into production, no deficiencies in the middle of the day. So they don't really have to, let's schedule the upgrade 04 p.m. on a Saturday, because that's where you have a bit less load. And then you have employees sitting up, you have people on call, and all the shebang. It's good, but if you can do it in a smarter way, in a more faster way, and you trust and you take in the steps in your innovation, that's a great way to be at. Like when we saw with OpenShift, with Magnus showed to us, it's a great way to handle it if you work in operations or application development. It's great to be able to push out changes consecutively during the day, and everything actually works. That helps you. Deutsche Bank, we have done lots of interesting things with them. They went all in OpenShift, and they're delivering everything as a service, and that's how they win the minds of the developers. So it's easier for them to attract people as well, easier for them to get the developers utilize the frameworks, to utilize the platform, and minimize shadow IT. I know, bank. Macquarie is also, it's an Australian investment bank, so it's also a bank. So let's call it a bank. It's a financial institute. So they moved to microservices on OpenShift in seconds, and for them, they are very agile. And then we have a governmental, GovTech in Singapore. They're focusing on innovation, social fabric, equality. And Singapore has a very special characteristics in their country. They have different races. They all work well together. They're working very much with having a good culture inside of their society. So they have governmental things going on there to build the social fabric for their citizens. So where do you start? So as you've seen, we had like 4 pillars, and it's still 4 pillars. So I would say that there are 4 pillars of cloud-native application development. There are great books about this. If you have spare time and very good memory, we have a head of engineering, Burr Sutter. He has a really cool talk that he does at DevVox, like with the flying elephant. It's really good. If you are bored, like technology, like speakers that have good inspiration, go to YouTube, search for Burr Sutter, and take a look at it. It's really good. So, accelerate app delivery. It's all about how to deliver faster. So, with OpenShift, we can containerize existing applications and use a high level of automation, as you saw when Magnus showed the demo. High level of automation, everything works great. Then we need to talk about modernizing the existing apps. Now we're starting to touch about how we make changes faster. The first is more about deployment, and now we're talking more about how we are handling our applications. So we're moving from Digital evolution, more to a digital revolution type of things. And that's when you need to look at OpenShift alone is not the answer for that. You need to run on some sort of modern cloud-native application runtime. In Red Hat stack, I would say that we have EAP, which is Enterprise Application Platform. It's a cloud modern native runtime that we recommend to our customers. And yes, it's Java EE based also, but it has some characteristics that makes it really interesting. Plus, you know, it's built by Red Hat, and we optimize it. We make it run really, really well on OpenShift. It's our strategy to answer to this market. Then, develop new cloud-native applications. Now we're talking about how to develop faster. Now we're talking about OpenShift application runtimes on OpenShift. We're talking about how to build new microservices. It could be mini services. You don't need to do microservices from scratch. And also the concept of a fast monolith. Everybody speaks about the monolith like if it's something bad, but I have also some ideas about that. And then drive business innovation. And that's completely different. That is how you drive innovation faster. We have a concept called Open Innovation Lab. It's really interesting. It's you get some bright minds into a room, you isolate them, you put up social contracts, you think of new ways to do things, and it's really a very collaborative and innovative, and it's like a bubbling chemistry lab. It's really amazing to see what happens when people come into that modus operandi. It's really cool to see that. So that's more of the revolutionary path when you want to create a change within your culture, and then how to adopt that culture later on into your organization. So that has those aspects quite a lot. So before we go further into the details, we need to define what are the characteristics of a cloud-native application. Service-based, yes. Everything has to go through APIs. No inter-process communication, no shared memory, none of that. Go through APIs over the network. Simple design paradigm, very difficult to live with it. So no backdoors. Use containers as deployment unit. For that will make automation better. And DevOps is very, very important because we need to develop the processes of how we do development and operations together, and where developers also have the responsibility in terms of operating this moving forward. So all of these are very, very important. If it's service-based, yes, everybody will say microservices. Yeah, great. But I think that a well-structured and well-designed monolith is also a good use case for this. So in the digital evolution, traditional, we have service-centric. It's cloud-native, it's container-centric. Nobody talks about VMs in a cloud-native environment. In traditional, we scale vertically. We throw in more memory, more CPU. Yeah, it scales better. Woohoo! If it's cloud-native, we've all heard about pets and cattle, blah, blah, blah. So it's basically about growing horizontally. In traditional, you have tightly coupled boundaries inside of the application in the monolith. In cloud native, you have loosely coupled and a concept of service-based. Traditional is typically infrastructure dependent. You've optimized it for a specific version of the operating system with a specific set of hardware. You've tested it. You know, everything is very well structured. In cloud native, it's portable across infrastructures. It has different types of characteristics. This presents problems sometimes. You talk to a traditional thinking customer. They say, I want cloud. I want running containers, but I need direct access to the hardware. It's like, yeah, okay, so you want containers, but direct access to the hardware, which means it's mission impossible because you're creating an affinity, so it's not portable. So you need to abstract your way away from it. Do it service-based. If you need GPU acceleration, work to get frameworks and services that utilizes that GPU, not give direct access to the IRQ or the interface itself.
That will be possible though.
Yeah, it is. The GPU acceleration is a part of the new version of OpenShift, so you can actually harness it. But to get like direct access and to bind it goes against the core principle of cloud native deployments, which creates lots of interesting challenges with keeping states, portability, managing it, how the service mesh should work. It just adds a complexity you don't want. So when I studied computer science, when we read software development courses, design patterns, etc., the first principle was make it simple. And that's the most difficult thing. To create a simple architecture requires a lot of thought and a lot of effort. Just write down everything sequentially so that goes very fast, but to segregate things so that everything becomes simple is very, very difficult. And this is definitively an area that's difficult. So in traditional, water files, semi-agile, long delivery times, so that's what we're trying to get away. In cloud native, it's agile. We have continuous delivery. Here we have local IDs, developer tools. Here we have cloud-based and intelligent tools. So in OpenShift, we do some acquisitions. We have a cloud version of our development board as well. So things are happening in this space. So we can spawn up instances like this, but if you work as a developer, you start to work at a new company, you have like 2 million lines of code. The first thing you get, this is your laptop. If you're lucky, they have good documentation. They give you this Bible and say, boom, install all of this, configure everything exactly like this, and you'll be able to compile the application. It takes weeks before you can even set up your environment so you can compile stuff. Are you agile then? No, because then you need to work another project. Another week is gone. And then, you need to fix something there. And then, I upgraded this version of Eclipse. It stopped working. We need to get away from that. And that's why cloud-based development tools are becoming much more popular. Of course, it's maturity, etc., but I think that is the future. What else do we have? Siloed organizations and teams. They work for themselves. Operations works for themselves. Then you have QA who says, no, doesn't work, doesn't go here. And then you have a security team that hasn't updated their policies for 100 years, so nothing is approved. So you just disable SE Linux because it's a pain. You don't know how to handle it. SE Linux disable, poof, and everything is great. But not when you do cloud native, because the high level of automation, the new processes, everybody needs to work together. So we're talking a lot about DevOps, but there's also a concept called DevSecOps, which is also security included, because that's also very important. No ops and collaboration. So if we look about the change faster use case, that is defined as increasing the speed of changing existing applications in order to adapt to market needs and customers. This can also be described as modernizing existing applications. And you can do everything in step-by-step model. You don't need to do everything at one go. Actually, I would recommend against it. So I stole this picture. I did. This picture was actually created by a guy called Martin Fowler. Anybody knows him? Yeah. If you don't know who it is, if you've read any of the famous UML books or design pattern book, he's probably the author. If you read about the actor-actor pattern, the fabric pattern, the singularity pattern, he has written a lot of these things. And this is his recommendation on an IDC paper. And we recommend a similar approach. Don't take the monolith, and move directly to a microservices architecture because a big dragon will fly and breathe fire on you and everything will fail. So it's better to implement new microservice applications as monoliths first. So make everything work. And then try to move slowly to a microservices cloud native way. That's the way to do it. And the reason for that is simple, because I mean, if you can't design and develop a monolith with segregated services inside of it, what makes you believe that you can do microservices correctly? I would say you can't. That's where the complexity comes in. That's where you want this super experienced and brilliant software architect helping you to do that, who has this kind of experience. If you don't have that kind of experience, there are other ways to handle it. Experiment. Take small services, break them out, see, are they grouped together in an efficient way? Is it logical? Experiment, try again. Fail fast. When you get through these different steps, you will be able to do things faster and faster. So don't do a rip and replace, do a small breaking out. Pick one service, break it out, route between them, one by one, and then eventually you will end up in a micro or mini service type of architecture. So the path is actually to take small steps, and if you try to create microservices from the scratch, it will probably be too complex. Everybody says that microservices, but what you do is that instead of having a large application who is calling functions and methods internally, you're separating them and then doing the calls over the network. If you do the design poorly there, you're actually adding a lot of latency if you do it wrong. If you're using the wrong type of protocols, the wrong type of service ideas, it's really difficult to get this working. So starting with the monolith is usually a good idea. Now, someone would shoot me, I guess, but I'm still saying it. So, so it's all about DevOps and how you move your organization. So the first step should be to reorganize yourself with DevOps so that you get development and operations. You start working in an agile process. And then you have to enable self-service access to the developers so that they can provision new environments in a fast and efficient way. Like Magnus showed with the horses and train. If they can self-provision, they can do things faster. Otherwise, you will be stuck because it takes too long time. I put every logic inside of this infrastructure, period, end of time. You will never move to DevOps or this new type of cloud-native workloads. So self-service is very important. And you need to have an automated continuous delivery pipeline. So automation is super, super important. So everything that can be done should be done in an automated fashion. No sideways, no shortcuts. Every change should go through a standard process. So if it goes through Jenkins, fine, but you need to have a standard process to do it. So, and you also need to have good deployment techniques so that you get continuous delivery. And you need to have advanced deployment techniques. So you can't really do an hour task or weeks of planning, or work all night. So this is where, like Magnus showed, you need to be able to move to canary type of deployments, red and green, blue and green, yellow, purple tomorrow, pink and white, whatever the paradigm is. But we need to move to and adapt to new things. And once all of these steps are done, and only then are you actually ready to move to microservices. So if you don't have the self-service product, don't try it. It's not going to work. You're going to fail. If you don't have the high degree of automation, it is not going to work because oh, I need to wait for someone to create the network. Oh, I need to wait for someone to open the firewall, and it will just bad. So these are very important steps when you move. So it can be microservices, or it can be the fast monolith, the monolith that is designed well, that you're utilizing in the right type of fashion. So if you effectivize your monolith into this entire process, I think that you have something that can be deployed into a cloud-native type of working and to that type of deployment mechanism going forward. Of course, then you need to start taking some other steps. So you need to look at what type of application server should I use, or what kind of is it Spring Boot? Is it, I mean, should I use Node.js? Should I use Ruby? I mean, you need to figure out what is right for you. But you can actually take the old application that is Java EE based, you can move it onto EAP, it doesn't just deploy it on OpenShift. So that's the absolute first step, to get it moving onto OpenShift so you can start deploying it in an automated manner. So you get collaboration around it. And for that, we have an application migration toolkit. Previously, we were having something called Windup. I'm not sure how many of you are familiar with it. What it basically does is that you drop a WAR file or an ER file or whatever file you have. It analyzes it, and it gives a really good feedback on what the level of effort is to migrate it. It has built-in intelligence, so it will propose. Let's say you're using WebLogic proprietary logger. It will detect that. It will suggest how you should write it to be Java EE standard space instead. It will give you lots of speed and acceleration when you try to migrate this workload. So it's all about helping to bring the workloads onto the new generation platform. It's free, it's open source, and well, of course, it can help you to write reports so that you can estimate how big of an effort it is to actually migrate this application, this legacy application. And let's see if we can have a demo working. So here's my mouse pointer. Yeah, of course, the sound doesn't go out there.
CLI, and there's also an Eclipse plugin. But let's start looking at the web console. I'm going to investigate the other one soon. So, in the web console, which is targeted...
Can you hear?
Yeah. More for giving a quick overview, being able to quickly scan through multiple projects, see and estimate the effort to migrate them, etc., so that we can quickly identify, for example, easy wins in initial projects, but also find which projects are potentially going to take more effort to migrate. So the way you do this is that you start a project. I'm going to start a new project called Store, and then you can point directly to a path where your source code is hosted, but actually even easier is to just point to a bar file. So I'm going to choose a file here. I'm going to point directly to the bar file. It's built of an application that is today built for WebLogic. So you can do additional settings here. So we want to see migration to EAP. We could set cloud readiness as well. We could select directly which packages to run, and we could do custom rules or advanced options. I'm just going to leave everything default right now, and let's save and run. So this will immediately start analyzing for us, and it's going to go quite quick, but when it's done, we can see the report, and estimates how much works and needs to be done. So if I go into the report, I can see details like how many are mandatory, optional, or potential type of queries. And we can immediately drill down into different types of issues we have, etc. But to be honest, that might be too much for just this tool at the start. A really good thing is to see how many story points is generated estimated approximately to migrate this application. So from that point, you choose which project to start with, and then a developer takes over, and developers, they should not have to go between report and developer studio. So we have already in developer studio integrated Redhat application migration toolkit. So here I have the same project checked out, the source code fully checked out, and when I run this project, what I can do in this project is, as you can see currently I don't have any errors, I only have some warnings, etc. Now, if I run this project, I already prepared a run project directly in Eclipse here, so all I have to do is click this run project. If you see this, it starts generating a report right now, and if we go over to the round view, we will soon see a report coming up here. Generating a report does take a bit of a while, but it's not too bad. And here we go, here's the report. So now I have the report directly in Eclipse, and actually what I can do is I can drill down directly to the issues. The issues also appear as problems now, so you can see wind up problem here. So it appears like problems inside Eclipse directly. But let's go and check here and drill down. I like this view. And when we go in here, we can go into, for example, the order service MDB here, and we can see what are the problems. Well, there's a mandatory problem stating here that we're using a non-catalog logger. So let's look at that. So the non-catalog logger is a WebLogic specific class that exists here. So it says WebLogic here. So we want to change that, and actually we can go directly to the issue and see why we need to change that. And it will say here, so there's a WebLogic proprietary logger here, and it's not supported in EAP and should be migrated to supported logging frameworks such as EDK logger. So let's do that. Let's migrate away from this proprietary logger. So it's actually two quite simple steps. Let's replace the import of the non-catalog logger, and then we'll change this to a logger type, and we'll actually do like this. We'll do logger.getLogger, and then we have already the class name in here. So that wasn't too hard. We can just organize our imports here, and then we can see, and it still reports issues here, and that's because I haven't saved this yet. So when I save this, and if I rerun the report, these issues will go away. So actually what I can do is I can click here, and I can say mark as fixed, and mark as fixed. So that was easy. Let's go for another one. Let's take a little bit more complex issue. So let's go for the startup listener issue here. So in this application, we're using a WebLogic application lifecycle event. Again, it's a proprietary feature, and we need to replace it. So let's change this application. Actually, let's see what we can find to help us change that. So here it says that we can change it to use startup and singleton. It doesn't actually give us all the details that we need. Well, the rule also points here to a knowledge article. So let's click on that knowledge article. When we go to the knowledge article, we can see that it provides a bit more detail, and we can see, do we want to replace the events using a servlet context listener? Well, actually, we want to go for the singleton stateless session beam, which is the CDI equivalent, the modern way to do this. So here we can see an example. So we can see that, okay, the first thing would probably be to remove these two imports. We don't want to use the WebLogic classes. And Then we want to annotate the class with startup and singleton. So let's do that. And let's also make sure that we don't extend the application listener. And we don't need that. And then we also need empty methods. It doesn't take a proprietary attribute as well. And instead of doing override, we do at post construct. And we'll also do at pre-destroy. And we just going to organize the imports, and we want to use, you can see here that we're using EEB, singleton, and startup. So let's do that. So that means that we can save this class, and our issues goes away. What I'm going to do, instead of having you watch me do all the changes, I've done the changes in another branch. So I'm going to go here, and I'm going to go back to this perspective, and I'm going to go here and say team, switch to migrated, and we're going to just dash the changes we've done. So now, if we run the report again, so same thing, we go here and we click the run. And so while we're waiting for that, let's see. So basically what we've been able to do is replace all the configuration that's part of the initial context with just annotations in here to say which queue and which type of queue and a bit of other configurations. So, but otherwise the class is the same. So now if we go and check the report again, it should generate, we can see that we were done. We have 0 story points here. So we are ready to move this application along. So typically the next step would be that we would check this into Git repository, and in that Git repository we would later on perhaps have a Jenkins or similar CI tool building on top of that, and actually probably running Red Hat Application Migration Toolkit from the CLI to verify that we don't have any outstanding migration issues, so that we can always keep track on how we're doing with the migrations. And then we will probably want to deploy that on OpenShift. But as a developer, before I push that, I probably want to test it on OpenShift. So let's see that a bit in action as well. So the next things, so what I'm going to do, I'm going to go back to the normal perspective, and I'm going to go into my OpenShift Explorer here. So I have a local mini-shift version running here on this address. So I can create a project here. Let's create a cool store dev project. And what I can say here is that I want to do a new application, and I'm gonna specify the cool store monolith as my project, and it immediately selects EAP for me here. So we're gonna select EAP basic, which is very simple applications, and then I'm gonna say next. And there's a couple of things we can do here. I'm gonna change the name to monolith instead, because this is still a monolithic application. And then we also rely on a queue in this application. So I need a queue to be configured. So I'm going to specify a queue called orders here. It's a topic actually, not a queue. And so specifying that topic will automatically configure Jabil's EAP on OpenShift with that topic specified. So with that, I'm ready to go further, and I'm just going to press finished and press OK. And now it has started. It should have started my build. So what I can do is I can go in and check my build log. Now we can see that the build log is downloading a lot of Maven repositories. So I'm using a really good internet connection, so this actually goes quite fast. But in many cases, that's not probably what you want to do with a round-trip development, to have it download every build. So there are different techniques to solve that, but one of the easiest one is to use rsync. And in Jabil's Developer Studio, do that automatically by creating a server adapter, which we're gonna look at in a second. Let's wait for this to complete. And there the build is complete. Now we can see that it's creating the pod. It says the pod is running. Let's check the pod log as well. Pod log looks good. EAP is coming up. And now it's started. That wasn't too bad. Up and running. So now I should be able to go here and say show in web browser. And here we got our application. Firstly, we took it from WebLogic, we migrated it to EAP, and then we deployed it into OpenShift. So here is the OpenShift cloud-enabled version of our. But so what's the benefit with all that? Well, one of the benefits is that we can run really quickly and develop really quickly, and we can also easily, like shown before, hook in Jenkins pipelines to build out to different environments, test and verify. So that makes us run very, very fast. So to illustrate that, but also to show that development life cycle is very fast, let's open one of the, we have a cool store CSS file, so let's open that. And in here we can, for example, let's change the header of the navigation background. So this will change the header here to red. As soon as I hit save, it immediately synchronizes the files. If I go in here and I click refresh, we can see we now have a red one. Red one, perhaps a bit too alarming. So maybe I want to change that to something different. So let's change that to something like ocean instead. So again, we save it, we go to our web application, and then we click reload, and now we can see the ocean headline. So that makes us very quick to run this and to do changes in here. Just to see that this is a full-on application, I can add things to the shopping cart here. And if I go to my shopping cart, see I have things in my shopping cart. I can also check out my shopping cart, and when I check out my shopping cart through GMS, it pushes it to the order system, and I now have an order here matching the price of my shopping cart. So that makes it really, really fast to do quick development, and at this point I would be ready to say that I'm ready to check this in, and then I would check it in, and we can have a pipeline taking over and deploying this. So this causes for a really, really fast-moving monolith. So with that, I'm going to conclude the demo.
Can I add here that actually Samuel started by talking about going to developers.bregðast.com. That's where you get this mini shift, which is a hyper-converged version of OpenShift in a VM image that you can run on your virtual machine. And it has all the functionality of OpenShift, so meaning that when you do deploy it into a production environment, actually on your laptop you have something which is the same, has load balancer, has a master, has a normal node, but it's all just running in one VM. That's
And why did I choose to show this? It's to illustrate the strength and capabilities you can get with modern toolkits. So probably one of the things that you would like to do if you want to move across this train is that you need to somehow migrate your applications. And here, without actually touching the code, basically removing proprietary function calls, identifying them, giving suggestions on how to rewrite them with sample code, etc. It goes much, much faster. You know, it helps you a lot. So that's basically what I wanted to show. So this would be the typical use case where you have your existing application, but being containerized, and you'll be able to utilize a lot of the automation steps and building. So it's the first step of dissecting the monolith to first get it up and running, to put a self-service portal, to do it in container-based, and moving all these steps that are required. And I also wanted to compare to these cloud-native runtimes. I stand here and I recommend JBoss EAP, but many say Java EE is very slow. We use Tomcat, we use Spring. What I want to demonstrate here is not who is best, but if we look at the start boot time, 2 to 3 seconds or 1 to 0 seconds, it doesn't really make that much of a difference. It's fast enough. Boot time including app deployment, it's very competitive. Memory utilization without load and with load, it is a cloud-ready type of architecture inside of this application platform, so it's definitively a candidate. Of course, the measured throughput will look times 2, times 3 compared to other technologies because, we are not that stupid. We do the standard configuration to run well on our software, so it's not a surprise that it will run better. Of course, everything is Java-based workloads. It's the same WAR file. Unless they have created really, really poor software, you can, of course, do tuning of parameters to get up the performance. But it shows that the out-of-the-box configuration is actually pretty good. So if we look at our customers, more than 50% is actually utilizing EAP on OpenShift for their microservices or actually considering it. I would say that Spring is also, or Spring Boot is very popular as well with flat jars, but flat jars also introduce some other interesting aspects that could be worth to take a look at. But I think that the most important thing here is that each micro or mini service can actually have its own runtime. You don't need to standardize on one. You maybe have different teams with different skill sets. You can mix and match. It shows that you have the ability to actually select what you want. And when Magnus did his demo, he also displayed that, you saw the catalog, he pressed PHP, I saw Node.js. So there are a lot of catalog items in there, but there is also the option for you to create catalog items. There is also an option to adopt and use container images. So there's lots of options and flexibility which framework you actually utilize for your development. Of course, we are eating our own dog food throughout EAP's life cycle from version 6 to 7 and 7.1 and 7.2. We are also moving to a DevOps type of process. So when I started at Red Hat, I think we did 2 releases per year. Then we started realizing that this is not how things are done in a modern era. We changed the entire build pipelines, etc. So we came down to be able to release once per month, which helped customers to adapt when the maintenance window, etc. are. And currently we are releasing a new minor release of EAP every 13 weeks. So it's a continuous improvement. New functionalities are coming. You're able to utilize them. We also have all these smart toolings that helps you to actually migrate the application without touching much of it. You have the application migration toolkit that can analyze and make sure that there are checks. So everything to do it smarter, put in more AI to make it more productive for the development, for the developers. So developer productivity is really, really important. So at the end of step 1, we will have something that is the fast monolith. So the second step towards modernization would be to replace this monolith, and that's basically what you're doing. You'll start looking inside of this application. What type of services am I having there? How can I separate them? How do I set the boundaries? A good practice is to use domain-driven design and define the components. But as always, that's difficult, more difficult than it sounds. You need to know lots of stuff. It's hard. So test and experiment boundaries a couple of times is probably the best approach. To be able to change, to have a culture and an approach where you can introduce changes rapidly actually makes you much, much better position to actually do DevOps, because you're actually doing DevOps on your own architecture as well, not only when you have defined architecture. So you can actually change continuously and all the time, and that's what you want to do. So the third step is to expose components through APIs, and don't use RPC. And I don't know why I said that, but the problem with RPC is you have to manage how do I handle failover of that protocol, because you put it in clear. It just creates problems. So use new technologies like AngularJS, web component, REST is also fine, but use something so that you can call to the services in the application. And of course, the first step is usually to expose the user interface or the web tier first, so that you can start calling them. The fourth step is using the strangulation pattern. So you replace piece by piece. So you start moving some of them. Maybe one is a flat jar, maybe the other one is Spring Boot. It doesn't matter. I would probably say that a good approach is to use mini-services. And a mini-service compared to a microservice is a set of services. So you call to a function like handle order, and that can be place order, read order, etc. So it can do many different types of calls internally. And then as step 2, 3, 4, or 5, actually move to a microservices architecture, which will also give you a way of doing things. We also have a nice little text here, optionally use tree scale and or fuse. And this is if you have specific routing needs. So if a normal routing is not enough, or you need to manage the APIs in some ways, you can do that. Of course, the OpenShift router can send it, as Magnus showed. So, and the fifth step is to actually retire the monolith. It means that you have implemented all functionalities as mini or microservices, and the monolith doesn't exist anymore. And in this step, the focus should be to look at the distributed architecture. So the concept of service mesh, canary deployments. A service mesh can help you to, let's say that you have customer A, or they will run this version. Customer B will run this version. How do I strangulate it so that you can actually create more complex patterns than what was able to do? Because maybe they are using APIs and you have retired them and they haven't had time to migrate. It gives you a lot of flexibility. Maybe you want to run early adopters, a friendly customer first for the new version to get it hardened in production. A production hardened system is a very powerful thing. That's why people are scared to move to a new major version and be the first customer that actually runs on it. Istio is not part of OpenShift today, but it's in the roadmap, and that's a service mesh functionality. So expect more to happen on that plane. Yeah, it's a tech preview, and the concept of tech preview at Red Hat is that we ship the functionality. We write in the documentation tech preview. It means if you have problems, you can't really create support cases, but for your development, you can start developing, utilizing it. You can experiment with it. Usually, not always, I have been burned too many times. Usually, the version after, it's a GA functionality, a generally available functionality. So it becomes a part of the product. You can use it in production. Rarely, I've seen them disappear, but it happens. So don't bet all your horses on a tech preview. Use it to experiment, understand technology, make an approach how you're going to consume it, and then wait until it actually comes out as a sharp version. So I also wanted to show some examples of customers that we have had who has used this application modernization steps. And potentially every OpenShift customer who wants to move their existing applications is a part of this. In some cases, Some authorities or some companies, they use OpenShift as a greenfield development thing. They do some new development on it, and it's like an isolated environment. But if you want to take a journey with your existing applications to move to a more modern cloud native approach, then you have to start looking at what do we do with the applications. And with that, I know we are not on time, we are a bit delayed, but I would like to thank you all and open up for questions.